You are given two lists of strings, queries, and dictionary. Every word uses lowercase letters and every word has the same length. One edit means change a single letter to any other letter. A query word counts if you can reach at least one dictionary word using at most two such edits. Return the list of query strings that satisfy that rule, in the same order as queries. Example 1. Compare query word to dictionary word would, letters match at 0, 1, and 3, only index 2 differs, so one edit is enough. Compare note to joke, two positions differ, still within the limit of two edits. For ants against wood, more than two positions disagree, so ants does not qualify. Finally would matches would with 0 edits. Output lists word, note, and would in query order. Since the lengths are identical, we can perform a direct index-to-index comparison. Every time the characters don't match, we count it as one edit. Think of it as a budget of 2 mismatches for this pair. Each differing index spends 1. If a third difference appears, this pair is ruled out and you move on or stop the inner scan early. For every word we want to check, we scan through the dictionary. We are looking for a hero, any single dictionary word that accepts our 2-edit budget. As soon as we find a match within the budget, we stop searching. We don't need to know how many dictionary words match, we just need to know if at least one exists. A query word only fails if it exhausts the entire dictionary without finding a single friend within the 2-edit limit. We process each query one by one. For every query, we will iterate through the entire dictionary until we find a match within our budget. For each dictionary word, we reset our difference counter to 0 and begin a character-by-character comparison. At index 2, we find our first mismatch. We increment our counter. Since 1 is still within our budget of 2, we continue scanning. We reach the end of the word with only one difference. This is a success. Because we found a match, we can immediately stop searching the dictionary for this query and move to the next word. Optimization is key. As soon as we hit 3 differences, we've exceeded our budget. We stop comparing these 2 words immediately and move to the next word in the dictionary. After checking all queries, we return those strings in query order. Each one stayed because some dictionary word was within the 2-edit limit. Worst case time is order Q times D times L. For each query we may walk the whole dictionary, and each pair scan walks every character. Space beyond the answer list is constant, a mismatch counter and a few loop indices. This is the same brute force structure as the solution walkthrough, nested loops over every query and dictionary word, a character scan that counts mismatches and can stop early once the count passes 2, then if the pair is still within budget we append the query once and break out of the dictionary search for that query.